So we are going to start our complex analysis. Complex analysis is not as complex as its name give us the rough idea of it. In fact, it is very math-like courses. It contains everything which you usually students expect from a math-like courses. Okay, so I don't think so. It is any difficulty you will find in it, but you have to be very very serious about it. Otherwise, it will be difficult for you. So start with them. So the book we will follow is Complex Analysis by Dennis Zill. So this is the book. If you do not have this book and want to read that, then I recommend to watch the video first and then read it, because I think so you will effectively read this book and get more idea of what actually the text contain if you watch the video, because I try to explain the things more for you, inshallah. But if you do not have that book, then the PDF of this book link is in the description box. And if you want the lecture notes of this video or this lecture, then this is also available in our description box. Go and check it now right below in this video. Okay, so start karte hain complex numbers. So the complex numbers have the story of, it is simply the story of complex numbers. Everything around complex numbers will be discussed in complex analysis. I will try to make things very easy, very normal, and very basic to you. We will not discuss very high level or very advanced things, inshallah, to make the thing very easy, inshallah. Okay, so start. So first topic is you stood about it is our imaginary unit. So before starting complex number, to study imaginary number is more important, because it is the part of that imaginary unit. So first of all, it has a proper notation, and it is oftentimes represented by iota. Not oftentimes, in fact, always represented by iota. This I'll look like I symbol called iota. So this is an imaginary unit, and the numbers and the real numbers with this iota called imaginary numbers, called over imaginary numbers. And remember that the real numbers are multiplying with over iota. Okay, so the numbers, like if we have a real numbers and multiplying with it, we get the over imaginary numbers, like of the form 2 iota is an imaginary number, like over 3 iota. So all the real numbers ai, where a belongs to our real numbers, are over imaginary numbers. Always remember that number. And very important thing about them is its value. The number of imaginary unit I is equal to under root minus 1. So it means that in 2 iota, in place of iota, I have actually the under root minus 1. Okay, in place of 2, I have actually written under root minus 1. Similarly, in 3 iota, I have the value of under root minus 1. So I want to, if you have any real number multiplying with iota, then it means that this real number is multiplying with under root minus 1. So under root minus 1 is equal to iota, is the value of our imaginary unit. Okay, I hope it is clear to you. Our next thing is the heart and core of this course, which is complex numbers. So write I want to write all the essential things for you in this slide and the next slide. So please write carefully all the things in your notebooks. So first thing about them is that any number of the form a plus b iota, where a and b belongs to our real number, are called our imaginary numbers. Okay, always remember that complex numbers are denoted by C with this cut or dash, with this line, or in books it is written by a capital C. Okay, capital C or capital bold C. Okay, and this complex numbers, like this, you can see complex numbers is of the form Z is equal to a plus b iota, where a and b are our real numbers. Then it contains two parts. One is our real part, and second is our imaginary part. Okay, the in imagine in real numbers, in complex numbers, in complex number, Z is equal to a plus b iota. A is called the real part, of Z. Okay, and in Z is equal to A plus B iota, then B iota called imaginary part of Z. By this, I mean, if I have a complex number like this, 2 plus 3 iota, then the real part of this complex number Z is equal to this is 2, because this in place of 2A, I have written the 2, but with the imaginary unit, I have 3. So the imaginary part of this complex number is over 3. I hope you can understand this. Okay? So very special thing. Okay. So if you have two complex numbers, remember that if in complex numbers, I'm written as this, A plus B iota is same as A plus iota B. So it is same. If I write 2 plus 3 iota and 2 plus iota 3, then both these numbers are same. Okay, I mean that. Okay. If I have two complex numbers, if two complex numbers Z1 and Z2 are equal, it means Z1 is equal to Z2. It means that, implies that real part of Z1 is equal to the real part of Z2, and the imaginary part of B2 is equal to real part of Z. Okay, if two compare imaginary numbers and they both are equal, then by this I mean the real part of one imaginary number is equal to the second, and the imaginary part of first real number is equal to the imaginary part of the second real numbers. Okay, so this is the very important condition for real numbers. Okay, the other important information about complex number will be written in the next slide. You can take the screenshot of it. Otherwise, the lecture note of this lecture is given in the description box. If you do not have the link of that book which we are following now, then I have given the link of that book, Complex Analysis by Zill, in the description box. You can also download it. Okay. So, other information about complex numbers can be it. So, any real numbers can be written in complex form, in complex numbers form. How, ma'am? Like this. If tell me any real number. If you give me a real number is equal to 2, then I can write it Z is equal to 2 plus 0 iota. Okay. If you give me 3, then I can write 3 is equal to 0 plus iota. So any real number can be represented in complex number form if we put 0 in the imaginary part. If we put 0 in the imaginary part, imaginary part of Z is equal to 0, then we will get real numbers. Okay. If Z is equal to 0 plus B iota, then this complex number, where real part of a complex number is 0, then this kind of a complex number is called pure imaginary number. Pure imaginary number. Okay, so any complex number with real part 0, we get imaginary number, and that imaginary number is called purely imaginary numbers. And very special thing about complex numbers are this, that complex numbers are called extension of real numbers. These are the extension of real numbers. And remember that real numbers are the subset of complex numbers. So real numbers are the subset of complex numbers, and these are the extension of our real numbers. Okay, so this is a very, very important information about complex numbers. Okay, so that is all from complex number. Our next topic is properties on real complex number. So complex number, if we have two complex number Z1 and Z2, if we add 1 into 2 or 2 into 1, I get the same result. It means commutative property holds. It means cumulative properties in complex numbers holds. Okay, if you give me three complex numbers Z1, Z2 and Z3, then if I add Z1 into Z2 plus Z3, or if I add Z1 into Z1 plus Z2 and then I add Z3, then I get both the cases same result. It means associative property in complex numbers holds. Okay, if you give me three complex numbers Z1 and Z3, and if I apply the distributive property in it, this is over Z2 is equal to Z1 into Z2 or plus Z2 into Z3. Okay, so this is over. It means that first complex number Z1 is distributed into Z2 plus Z3. So it means distributive property also holds in complex number. So remember that cumulative property, associative property and distributive property in complex number holds. Okay. Okay, then we will now move to our next topic, which is how to apply the operations on real number or complex numbers. So what is the operation? You all of us knows that there are four basic operations we can perform on any type of number, which is over addition, which is over subtraction, which is over multiplication, and which is over division. So there is special rule. You cannot multiply complex number as you do in real number. So there is difference there. So how to, first I will elaborate how to add or subtract two complex numbers. So here in complex numbers, if we add or subtract complex numbers by adding or subtracting real part into real part, and imaginary part into imaginary part. For example, if I have two complex numbers like this, 2 plus 3 iota, and the other is 5 plus 6 iota. Let's say Z1 is this and our Z2 is this. These are our two complex numbers. So how I can add it like this? Z1 plus Z2 is equal. The real part of the first complex number is 2 and the real part of the second complex number is 5. So I add the real part of first into real part of the second plus iota as it is, and the real part, imaginary part of the first into plus imaginary part into of the second. So 3 plus 6. So in the end we get 7 plus 9 iota. Simply, say we will follow the same pattern in our subtraction. In our addition, in our subtraction, we will do the same thing. Okay, okay. So now, how to multiply two complex numbers? I am going to take this complex number, and now I am performing the multiplication. The complex number is 2. So we have two complex number. Z1 into Z2 is equal to 2 plus 3 iota into 5 plus 6 iota. So how I can multiply them? So multiplying in multiplication, we do apply distributive property. So remember that in multiplication of the complex numbers, we use distributive property. Okay, how I can? So it means we will distribute the first bracket into second. So 2 into 5 plus 6 iota plus 3 iota into 5 plus 6 iota. Okay, so we will get 10, 12 iota and 15 iota together becomes 27 iota plus, okay, we get 18 iota square. And remember that iota is square because in the latest slide I have this iota is equal to under root minus 1. So iota square is equal to minus 1. So in place of iota square, I will write minus 1, and this minus 1 becomes minus 18. Minus 18 plus 10, we get minus 8. So we will get minus 8 plus 27 is the answer of our Z1 into Z2. So this is the pattern and the method you will do in our multiplication. In multiplication of the complex numbers, we will do distributive property, while in the addition and subtraction of the complex numbers, we add or subtract the real part into real part and the complex part into our imaginary part into imaginary part. Okay, I hope it is clear all to all of you. Okay, our next topic is zero and unity. It means we are talking about this and this number. So always remember that 0 is the complex number. Is the complex number. Is the complex number of the form in which real and imaginary part is 0. So 0 is the complex number where real and imaginary part is 0. And it is also called, 0 is also called additive identity. This 0 in complex number is called additive identity. Or how is it additive identity? You can see that if I add any complex number into 0, I get back that complex number. For example, if I have z is equal to 2 plus 3 iota, then if I add 0 in it, I will get 2. So in addition, I will add the real part of 0 with the real part of this complex number and the imaginary iota as it is and the imaginary part of this complex number into 0. So I will back get z3 2 iota plus 3 iota. So same, okay? So this is a very important thing about 0. So 0 is here with us. So all the essential information about 0 is here. Okay. 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 So now unity. Unity is over 1. And remember that 1 is also the complex number. Also the complex number of the form where real part is 1 while the imaginary part is over 0. So 1 is the complex number of the form this. And this unity is also called in complex number is called multiplicative identity. Multiplicative identity. How is it a multiplicative identity? Because if you multiply any complex number, you multiply any complex number with 1, you get back that complex number. Okay, you get back that complex number, like 0 into complex number into 1 is called again C. For example, if I have this complex number 2 and into 1, then it means that I have to multiply 2 plus 3 iota into 1 plus the 0 iota. Okay, so how I can multiply them? Then it means distribute 2 into 1 plus 0 iota. I will distribute the first bracket into second, then dot as it is 3 iota into 1 plus 0 iota. So I will get 2 iota plus 3 iota, which is back over complex number. So remember that 1 is over multiplicative identity while 0 is over additive identity in our complex numbers. Okay. Okay. So our next topic is conjugate of complex numbers. So this is a very important concept and very interesting in complex number. So not very difficult. It is a complex number is denoted by Z bar. Conjugate of complex numbers we will get by changing the sign of imaginary part of changing the sign of imaginary part of Z. Imaginary part of Z, we will get the conjugate of this. For example, if I have number Z is equal to 2 plus 3 iota, then I will get the conjugate of it by changing this sign of the imaginary part. Here, or imaginary part is plus 3 iota, I will write is minus 3 iota. This is our Z bar. So Z bar is equal to 2 minus 3 iota. You can easily see that z is equal to 2 plus 3 iota, but my z bar, it means z conjugate is equal to 2 minus 3 iota. So this is the method you can take. You can take over conjugate over complex numbers. Okay. If you have two complex numbers, if you take the complex numbers twice, then we will get back that number. For example, if I again take the if again I will take again the conjugate of it, I will get back this number. Okay, always, this is a very important property of complex numbers. And if you have two complex numbers, very important properties of them, very important. If you have two complex numbers and multiplying with each other, and you take the conjugate of them, then you can separate them like this. Is equal to that if you multiply complex z1 conjugate into z2 conjugate. Okay, similarly, if you divide two complex numbers are divided by each other, then you can separate them. Similarly, if you have two complex numbers and added with each other or subtracted by each other, you can separate them like this. You can easily verify them. These properties are very important properties of them. Okay. Okay. And okay, it is very important. It helps us in division. It helps us in division of complex number. How it will help us, I will elaborate you inshallah the last part of this video. So this is it from conjugate, and the all other essential information about them we will return in the next slide, which is this. So the very important thing about that is if you sum or difference, the difference, okay, the sum and the product of two complex numbers, sum and product of two of complex number with its conjugate is real number, is a real number. How? So if you multiply or add one complex number with its conjugate, you will get the real number. It means if you have I will write it very badly. Okay, if I add complex number with its conjugate, I will get the real part of z. I will get the real imaginary real number. I will get the real part of z. Okay, I will get the real part. I will get it 2 into real part. Or if I multiply if I multiply a complex number with its imaginary part, I will get again real number, which is a is equal to a plus b square. How? You can see that z is equal to a plus b iota and z bar is equal to a minus b iota. Okay, so if I add them, so I have to add the real part into real part. I will get this and iota as it is, and okay, and add the imaginary part of one into imaginary part of the other. So b minus a. So I will get 2a plus 0 iota. Then I will get 2a and 2a. So I can write it as real part of z. So you can see that I can drive a formula that z plus z bar over 2 is equal to the real part of z. This is a very important formula which we will use in our questions. So remember that, always remember that z plus z bar is equal to z plus z bar over 2 is equal to the real part of z. Okay, real part of z. So now the multiplication of the okay, I will take the okay. So the multiplication of the real. So if I have a conjugate, so a plus b iota. Now I verify this result for you. So a minus b iota. So how I can multiply them? By using distributive property. So a into a minus b iota plus b iota into a minus b iota. So we get a square minus ab iota plus ab iota and minus b is square iota square. So this will cut with this. So we get a square minus b square, a square minus b square and iota square. So you can always remember that, you will remember that iota square is equal to minus 1. So I am plugging that here. So I will get iota square is equal to -1, so I get a square plus b square. So this is it. So remember that if you multiply the complex number with its complement, you will get this, which is a square plus b square by this. Okay. So this is the remember that the sum and the product of the complex number with its conjugate is real number. You can see that a square plus b square will always be equal to the real number. It will be a real number. And here also we get the real part. Okay. Very interesting. And similar to that result, you can also write this fact in your notebooks that the difference of two complex numbers is equal to imaginary part of z. Imaginary part of z is equal to the imaginary part of z. You can verify it that z minus z bar over 2 is equal to the imaginary part. You can verify this thing by in the same way as I do it for addition. You can find it that a minus, you can find it in your notebooks and verify that result, and a minus b iota b bar z minus z bar over 2 is equal to over imaginary part of it. So these three formulas are very, very important, and we will use them in our questions. Okay, so these are very important things. So the division of the complex numbers, we can do it in this video, but it is already become very long video. So the division of the complex number we will do in the next video, inshallah.